Hi and welcome back to module number 10, implementing monitoring, elasticity and high availability. We are working on a challenge lab today, which is creating scalable and highly available environment for the cafe. So in this lab, what we'll be doing is that we are launching multiple EC2 instances behind the Elastic Load Balancer. We'll configure auto scaling groups that the environment automatically adjusts capacity based on the demand, and then we'll ensure that the application is fault tolerant and remains available even if the instance or the availability zone fails. We'll learn how AWS elasticity and redundancy improve the performance and resilience. So we'll be going through step by step on all of these things which are here, and just like our guided lab, we have two availability zones here, and they are both connected by an internet gateway, and we have a public subnet and a private subnet in both availability zones, and then we have a NAT gateway at the moment over here, and there will be an AMI that we'll be using and a database instance. Towards the end of the lab, we'll be able to accomplish this thing, that in both availability zones we'll have our public subnet 1 and public subnet 2 in our second availability zone. We'll have separate NAT gateways. That's for the security purposes. It's necessary to have separate NAT gateways so that you can maintain the IP address sequencing over there. Further, we'll be using an AMI for the Café application servers, and we'll be using auto scaling in between them. And then on our availability zone 1, we'll see a primary database instance on our private subnet. So the duration of the lab is around 90 minutes, and then we'll be accessing the Amazon Web Console or the Management Console. And just like the hands-on lab or the guided lab, we'll inspect the overall environment first of all on our VPC, and you'll have to answer these multiple choice questions, and then we'll continue updating the network access across multiple zones. So let's start our lab by going to VPC first of all, and we'll check on your VPCs, and we'll see your lab VPC over here. Now in this one, as you can see, the resource map that we have lab gateways, NAT and everything already connected to our network connections, and we have a route table over here. We'll be adding a NAT gateway over here soon, and then you can see that our both public subnet and private subnet are on different availability zones, and they are going through different route tables. You can even find the IP address and their associations over here. Further, if we'll go to the subnets, you'll be able to see the public subnets and private subnets over here, and they are all available. They are working. If you want to see the routing tables, we have the routing table information available here, if they are connected to the internet gateway, and if they have any subnet associations, or if you have any tags, if you have defined it, or they have prepared the environment according to that. On the internet gateways, you'll find only one internet gateway over here. If you will click on this one, you'll be able to see the details for the lab internet gateway, and if you'll click on the second one, which is for the VPC, which was there already, you don't see any details on this one. Further, if you look at the network access control list, you can see that there are two at the moment. One is the one that we'll be using would be lab VPC, and it is also connected and showing the inbound and outbound rules on this one. Further, if you'll go to the security groups, you'll be able to see the Café SG, and it has its inbound and outbound rules, and you can see that at the moment that it is only allowing the traffic on HTTP port 80. So we went through the setup for task number 1. Now we are starting task number 2, which is updating the network for to work across multiple availability zones. So we'll create a NAT gateway in the second availability zone. This NAT gateway would allow our private instances to connect to the internet for updates and downloads, but still prevent direct inbound traffic. By having the NAT gateway in each availability zone, we remove a single point of failure and make sure that our resources are resilient. So they are giving the information of that we'll be launching a template, and then we'll be creating an AMI with the name of Café, and we'll be using T2 micro for this one, and then we'll create a key pair and we'll name it as Café SG, and then we'll enter the details for this one according to the instructions. So in this, we are creating a launch template as well in task 3. So a launch template is like a blueprint in EC2 instance. It defines the AMI instance type, key pair, security groups, and the user data scripts. So by using the template, every new instance created in auto scaling will be consistent, saving time and reducing the errors. So in order to start now task 2.1, we'll have to go to your VPCs, and in your VPC, we'll look at the resource map, and you can see that at the moment, and if you look that we have a public subnet and a private subnet over here in two availability zones, and our public subnet one is routing to internet gateway through our routing table, and private subnet is also going through a routing table to NAT. But we don't have any NAT connection for private subnet over here, so we'll have to create this connection, and that's what they are saying in our instructions manual. So if now you want to create a NAT gateway for your private subnet 2, we'll have to go to our NAT gateways. So we'll click on NAT gateway and then click on create NAT gateway. I will name it as NGW-2. Now under the subnet, we are going to select our public subnet 2, since it's already available in the first public subnet, so we don't need to create a NAT gateway. We are creating a NAT gateway for public subnet 2. Then like always, we are going to click on allocate elastic IP address. It would automatically assign an IP address to this one, and after that just click on create NAT gateway. And as you can see, it would show an option that the NAT gateway 2 has been successfully created. After that, we'll go to the route tables, and here select public route table 2. Sorry, our private route table 2. Click on this one, and here we'll add it to add a route. And here we'll select 0 and we'll select a NAT gateway, and in this one we'll select our NAT gateway 2 and save changes. Now let's check it by going to our VPC and check on the resource map. So if now you'll see that your private subnet is routing to your NAT gateway 2. So that was our task 2.1, which is creating a NAT gateway for the second availability zone. Now we are starting task 3, which is creating a launch template, and we'll be following these steps. So for that, we'll have to go to our EC2 instance. After that, click on instances, and you'll be able to see the instance which is running. But we are creating a new launch template, so we'll have to click on launch template and then create launch template. Here we'll name it as demo LT, which is our launch template. Then we'll scroll down, and under application and OS images, I'll click on my AMIs, and then you'll be able to see my Café web server. Make sure that it is selected. Further, in instance type, we are going to select T2 micro as per the instructions on our instruction manual. Further, if we'll scroll down, then they are saying to create a new key pair. We can call it as key and create a PPK and create a new key, and as you can see, it is downloaded as well. Then we'll go down. We are not making any changes here. In the security group, we'll select the Café SG and then move down. Then we'll scroll down, and under resource tags, we'll add the tag as per the instructions. And then I'll enter the resource tags as name, web server, and here I selected instances. And then on advanced details, under IAM instances, I'm using Café role. And after that, we'll just click on create launch template. That's done. If you want to see the template, you can see it over here. So we have completed task number 3. Now we are starting task number 4, which is creating an auto scaling group. So in auto scaling group, this group would automatically adjust the number of EC2 instances based on the demand. So if traffic would increase, it would launch more instances. If traffic would decrease, it would terminate unnecessary ones. So this would help us in balancing the performance and cost effectively. So in order to do that, we'll be going to auto scaling group, and then we'll launch a template and VPC, and then we'll be entering these details as 2 to 6, and then rest of the other options. So let's do it on the management console. So now in order to do that, we'll select the instance that we just created, then go to actions and click on create auto scaling group. I named it as demo-asg, which is auto scaling group. Then under the launch template, you can refresh it, but that's the template that we created. It's already appearing there. After that, we'll click next. And then in this, we'll go to network and we'll select our lab VPC. So in next step, they are asking about the availability zone and subnet. So as per the instructions, we'll have to select private subnet 1 and private subnet 2, and just verify that they should be on 2 different availability zones. Then we'll scroll down, and we are not making any other changes. Just press next. In this screen also, we are not making any changes. Just press next. So here desired capacity would be 2, and then minimum desired capacity would be 2 as well, and the maximum desired capacity would be 6. So we are deciding the scaling capacity of this one. So desired capacity is by default it would be 2. Minimum is the requirement, which is 2, but if there would be a load, it would run 6 different instances of it. For automatic scaling, they are saying to select target tracking scaling policy. We'll keep the target tracking policy as it is over here, and for the target value, they are asking us to enter 25 here, and instance warm-up is 60. After that, we are not making any changes here. We'll keep the capacity reservation as default. Press next. There are no notifications at the moment. We are not adding any tags as well. Just review the settings, whatever you have selected. Make sure that the subnet details and different availability zones are there, and then just scroll and create auto scaling group. So we have just completed our task number 4, and we entered all these details. Now we are starting our task number 5, which is creating a load balancer. So the load balancer would evenly distribute incoming traffic across multiple EC2 instances in different availability zones. This will not only improve the performance, but would also ensure that if one instance goes down, the traffic is routed to the healthy ones. So in order to do that, we'll create a load balancer with a name, and then we'll have the subnets and HTTPS and the security groups associated with that, and then we'll skip registering targets over here. So in order to create a load balancer, we'll go to our load balancer over here. On left hand side under load balancing, click on load balancers. And here we'll click on create load balancer. Under application load balancer for HTTP and HTTPS, we are going to click on create load balancer. So then give it a name as demo LB, which is demo load balancer, and it should be internet facing. We'll keep IPv4 over here. Here we are going to select lab VPC, and here under the availability zones and subnets, we'll select US East 1A and US East 1B, and just make sure that you're selecting the public subnet over here for both of them. Then we'll scroll down, and under the security group, just make sure that you remove the default one, and we are going to create a new security group over here. Now this security group will allow the HTTP traffic from anywhere. So as you can see that it is for web server, so I'll call it as WebSG, and we can even give it a description as well. I entered the description and then select our lab VPC. So we'll create an inbound rule over here for HTTP, and we'll select custom and then select 000. We are not doing anything else over here, and scroll down, create a security group. So now if we'll go back and if we'll refresh here, we would have a security group which is WebSG. We are going to select that one and remove the default group. Then we'll scroll down under forward target group. We are going to create a new group over here. We'll select the instances and we'll name the target group as demo TG. After that, I'll keep it protocol as HTTP IPv4, and just make sure that your lab VPC is selected over here. And after that, we'll scroll down and just press next. Now you remember when we were working on guided lab, we registered the targets, but here we are not registering the targets because we want our auto scaling group to automatically detect them and launch if they are required. So we'll scroll down and we'll create a target group. Now we'll go back to our previous application load balancer and we'll refresh it, so we'll be able to see our demo target group over here. After that, we'll not make any changes over here. Just check the summary of it, make sure that your settings are okay, both availability zones should be there, and your WebSG, and create load balancer. So we have just created the load balancer. It would take few minutes to complete. You can refresh the page and wait for it to be available. Once it's available and the status changes to available, then we'll start working on it. So after a while, if you'll refresh, you can see active over here. Now we'll have to update the auto scaling group so that it can work with the load balancer. So you'll go on your left hand side and click on auto scaling group, and then select your auto scaling group, and we'll have to integrate it. So we'll be clicking on integration, and as you can see that it's not showing any load balancing details over here. So in order to add it, we'll click on edit load balancing, and then we'll select on application and we'll select our demo target HTTP, and after that hit update. And as you can see, now under load balancing we have demo TG, which is our target group. So if you want to see it, we can go to target groups and we can check it over here. And next, if we'll click on demo TG, now you can see that our both web servers are listed up here, which are registered targets. So now with that, we have completed our task number 5. Now in task number 6, they are saying to test the load balancer and testing the web application without load. So in this step, first we'll test the application with normal traffic, then we'll simulate heavy load and see if auto scaling launches new instances or not. So if we are talking about testing the web application, we'll simply access the web application through the load balancer with the DNS name, and we'll refresh it a few times to verify that the traffic is distributed across different instances. Now this would confirm that our load balancer is working perfectly fine. So since we are testing the load balancers, I'm gonna click on load balancers on your left hand side, and then open your load balancer, and we'll copy the web address for this one. And if we'll open it in a new tab on browser, it would show us that hello from your web application server. Next up, they are saying that once the website would load, just change the address for this one as cafe and press enter. You should be able to see this website as well, which is actually hosted on their servers. So we have completed step 6.1. Now we are testing automatic scaling under load. So here we'll generate an artificial load on our application using a stress test tool. As the CPU utilization would go up, auto scaling policy should trigger the creation of new EC2 instances, and after a few minutes we should see that additional resources are running. Once the load decreases, auto scaling would scale the environment back down. Now this would demonstrate the elasticity in action. So they are asking us to run these commands and run a stress test on our instances. So to load test our instances, we'll go to our instances which are running, and after that select any of the instances from here. So you can choose any of these instances. For example, if I'll select the second one, and then if I'll click connect, and after that go to session manager and click connect, it would open another window with a command line interface. So we'll copy the commands from the instruction manual and paste it over here. Type the command and then press enter. After that I'll install the stress test utility, stress -y, and press enter. So we'll provide the parameters for stress test for one CPU and press enter. So what this would do is that it would have an artificial load on our CPU, and it would trigger multiple instances of our VMs. So we want to see that if there is load on our VMs, if it would automatically scale to 6 VMs as we defined earlier. So you'll have to wait there for a while, and if you'll go to your EC2 instances now, and then if you'll click on auto scaling group, and then click on your auto scaling group, click on instance management and wait for a while. As you can see that at the moment there are only 2 instances, but once it would detect that there is a lot of load, it would start 6 instances simultaneously. Now as you can see, once we refreshed, it automatically scaled to 6 instances. Since we gave 600 seconds time, it's equal to 10 minutes. So it would check that if it would continue for around 10 minutes, it would automatically run multiple instances of it. Now if you want to check actually that what is the statistics in the background, and if we'll go back to the stress test and you'll check the details on this one, that we actually ran the stress test on 580, and if we want to see the details of 580 on our auto scaling group, this is the server on which we had a stress test. So if we'll click on this one and we'll click on monitoring, so you can see that the graph went up. So it detected that there was a lot of load on this one, and that triggered the initiation of multiple instances. You can further see these details on CloudWatch as well. So if we'll go there, and if you'll check on alarms and click on all alarms, you'll be able to see that something triggered over here, and you can see the date and time of it as well. So if we'll click on any of them, we can see the actual reason of spike, and as you can see that there was a spike over here because of the sudden stress test on the VM. So that's what we tested in our last step, and we have built a scalable and highly available environment using AWS services including EC2, auto scaling and load balancing. So in a nutshell, we learned how to design and deploy a scalable and high available environment in AWS. Step by step, we updated our network to span multiple availability zones. We created a NAT gateway for secure outbound access, built a launch template to standardize the EC2 instances, and configured an auto scaling group to automatically add and remove instances based on the demand. We also deployed an application load balancer to distribute the traffic evenly across our instances. And finally, we tested the setup by observing on how to load balancer handle the traffic and auto scaling response to the increased load by launching new instances. So that was our lab for today. I hope you learned something new. That's it for today. Thank you very much.